and I'll be going over the fundamentals of object-oriented programming. And to put it simply, this is an approach to programming where we organize code through classes and objects. And for this presentation, I'll be using cars as an example to help explain these concepts. So let's first talk about objects. If we think about a car, it might have different qualities and attributes, such as color, speed, or the different actions that it has. And specifically for actions, these are actually called methods in a Python class. And it might be able to brake, drive, brake, or honk. And so OOP, or object-oriented programming, gives us a way to describe the characteristics for a car and the building blocks that build the car in the code. So to do this, we first need to create something called a class, and this is defined with the class keyword and then the car name, class name. And the easiest way to think about that is a blueprint. So for this blueprint, there's a few different things that it needs to have. The first of which is a default constructor, which is called double_init. And this is where all the different qualities for that car is stored. So it has the color and the speed. And then within this class or blueprint, there's also methods. So one example could be it has honk method. And then if we want to actually create the car from this blueprint, we have to instantiate it. So we would define a variable and then say we would call the default constructor, which is simply the class name, and then we could provide any parameters, but if we provide none, it will just use the default values. And an easy analogy to think about is if you're building a Lego set for a car, the Lego set might come with instructions, and that is the blueprint itself. But the final result after putting together all the Lego pieces, that is actually the object, and that's created from the blueprint or instructions. So now that we understand what classes and objects are, let's talk about the three pillars for OOP, and these include encapsulation, inheritance, and polymorphism. So the names for these might sound really complex at first, but they're actually much simpler than their names. So we'll go over examples of how these work. So the first one is encapsulation. If you think about driving a car and you want to go faster in the car, you might press on the gas pedal. But the driver wouldn't need to know or care about how much fuel to add to the car or how much to calculate to make the car go faster or how to control every cylinder in the car. All of that complexity, as you can see here, is hidden behind the gas pedal, which is the higher level implementation to allow you to control the wheels. And encapsulation in programming is the same. So we basically hide all the complicated details behind in the class and then give other parts of the program and expose the more higher level implementation to the user. So they can just simply call the method to press on the gas pedal rather than care about all the underlying details. And then next up we have inheritance. So imagine that we already created the base blueprint for the car, but now we want to create a blueprint for a sports car. So a car already knows how to drive, brake, and honk, but a sports car, it has the same exact functionality at its core, but it simply just adds on this launch control function from the car. So it wouldn't make sense to recreate the entire blueprint from scratch. Instead, what we can do is inherit from the car base class and then add on specialized methods to the sports car blueprint. So basically it says, hey, start with everything the car base class has and then change or let me add specific things for a sports car. So inheritance lets us basically reuse and build on things that we've already created. And then finally, we have polymorphism. So let's say our regular car has a function that's called start, as you can see here. This car, and then we want to create an electric car that also has the function named start. But for electric car, it doesn't have an engine, but it has an electric motor. And the way that electric motor might start up is different from a gas engine. So if we want to use the same function, we can, and we can do that with polymorphism through overriding. So if we inherit from the car base class, we can override the start function and then put all of the different complexities of how electric motor might start, and that might be different from how a gas engine starts. But you see how the name for the function still stays the same. And then one important thing to mention is that these ideas for encapsulation, inheritance, and polymorphism don't exist separately. They all work together. So encapsulation allows us to hide all the complicated details. Inheritance lets us build more specialized cars like sports cars and electric cars. And then polymorphism lets us change those specialized methods in the same base car method, in the same base class, but make them respond differently and act differently. So together, overall, it makes the code more easier to organize and reuse. So if you remember nothing, remember that a class is the blueprint, the object is something that we create from that blueprint, and then our three pillars help us work together with those blueprints. Encapsulations helps us hide the complexity, and then inheritance lets us build new blueprints upon the ones that we already have, and then polymorphism is letting us create related objects from the same action but in different ways. And that's pretty much the fundamentals of object-oriented programming. Thank you for watching.